Welcome back. So this is our second part of the fifth lecture. Let me share my screen and keep working on the model. So again, this will be a toy model with one good, one firm, one consumer, and one production factor. So let me now open a new page and discuss the model environment. Okay. So first of all, which is important, this one is very important. The model is static. There is no time. Okay, so this is a timeless universe. Now, in terms of demography, one household. Okay. In terms of endowments, this household has 1 unit of time and nothing else. Now, what happens to this time? Well, it has 2 uses. First, it could be transformed into labor supply. Okay, H is labor supply, and the remaining time will be leisure. Okay. Then you of course define the preferences. All right. So for the preferences, we're going to have this utility function. Okay. We're going to define this utility function. And utility function looks like this. Let me double check. Sometimes I forgot my own model. Yep. So here we assume alpha is between 0 and 1. Okay. So in this, according to this utility function, I care about consumption, and the part of utility function that depends on my consumption level is logarithmic. Okay, so this is the natural logarithm. And the utility I get from leisure and consumption are additively separable. Okay, this is also for simplification, of course. And the part of utility function that depends on leisure is linear. Okay. Next, I define the technologies. Okay, so there is only one technology. So there's a production function, and this production function is like this. So here, X is productivity, which is exogenous variable, and beta is between 0 and 1. Okay, so here, H is labor demand by the firm, Y is output, and X is productivity. And productivity is exogenous, okay? So that's the model environment. Okay, again, let me double check one thing. Yep. Okay. So I have the demographic structure, only one household. This household has only 1 unit of time. This time input has 2 uses, labor supply and leisure. Then we have the preferences for this household. The utility function depends on the consumption and leisure. And finally, there is a production technology. So this is the good, this is the consumption good, and consumption good must be, of course, produced, right? And this is the production function. In the production function, we only use labor, and there's decreasing returns with respect to labor because beta is between 0 and 1, right? And X is some exogenous measure of productivity, okay? That's the model environment. Now, we're going to discuss market structures and ownership structures. Okay? So, how many markets we have in this economy? Well, we have two markets. One is the labor market. The other is good market, right? Labor market and good market. Now, we assume that in both of these markets, all agents are price takers. So we also say, I mean, sometimes they are, of course, they are related things, but we say these markets are perfectly competitive, all right? Now you should stop me here and explain, or demand for me to explain how in a perfectly competitive market there is one seller and one buyer, right? Because we have one consumer and one firm. Okay, how can this market be, how can these markets be perfectly competitive? Any ideas? Now, this is a trick, okay? And here's how. So imagine that these are the firms, okay? Imagine that firms are indexed by I and households are indexed by, let's say, J, okay? Now, in such a situation, you have an infinite number of firms, okay? Infinite number of firms and an infinite number of consumers, right? Because they lie in the unit interval, all right? Now, if I say every one of them, every firm is a price taker, okay? Then I basically force my model to feature perfectly competitive markets. Why? Because if a firm is a price taker, even if there's one firm, that firm will not exercise any power to determine prices, okay? Or if there are many consumers that consume the consumption goods and that supply labor, and if consumers have no power to affect the equilibrium price or the equilibrium quantity in both of these markets, then again, there will be, these markets feature perfect competitive features. But here, in this toy model, I have only one consumer and one firm. Well, it is not a big problem because these firms are, consumers are identical, okay? So if you imagine firms are located within the unit interval, but each firm has the same level of labor demand and same level of output, okay? And if consumers supply the same amount of labor, okay, and consume the same amount of consumption, then these imply aggregate quantities are the same as average, okay? Remember integral, right? Because these are 0, 1, 0, 1, 0, 1, 0, 1, right? So this is the trick I use to make this model perfectly competitive, but still have one consumer and one firm. Because even if there are n infinite numbers of firms and consumers, I assume that they're identical. Since they're identical, the averages are equal to the aggregates. Okay, so that's a mathematical trick that we sometimes use in such frameworks. Okay, so let me go back to my market structure assumptions. So there are two markets again. One is the labor market. So in the labor market, the firm is the buyer, and the household is the seller, right? In the good market, firm is the seller and household is the buyer. Okay? So if firm is here, household is here, so goods go to, so labor goes from households to firm, and output goes from firm to the household, all right? Here it is labor demand. So if I do this, in the firm it is Y, in the household side it is consumption. And of course, there's wage going to there, and there is price going to there. All right. So this is the simplest thing that you always knew, but here shown to you in a different way. Okay. Now the ownership we should also discuss. Oh, by the way, we should also say this. Yes. So there is this price level, okay, and there is this wage level. All right. So these are the two prices. Why do we have two prices? Because we have two markets. Okay. With two markets, we must have two prices. Okay. Now in the ownership structure, you should realize one thing. With this production function, okay, what is the profit? Profit is P times Y minus, what is the cost here? Cost is only wage, right? So if you write this, you have price times productivity times labor to the power of beta minus that. Now realize one thing. If the firm takes these prices as given, right? Since this production function exhibits decreasing returns to scale, there is always positive profits. Okay, so basically there's an inframarginal rent here, right? There's a hidden factor here that makes the production function to exhibit decreasing returns to scale. Because of decreasing returns to scale, even under competitive conditions, there's always positive profit. So that profit needs to go somewhere, right? That profit needs to go somewhere. And we assume that the household owns the firm. Okay? If the household owns the firm, then profit goes to the household's income. Okay? So that will be important. Why? Because this is a general equilibrium model. If there is some money out there, that money goes to somewhere and to be spent. Why? Because in a general equilibrium model, we were going to have Walras law. So all the money should be entering into some account. Okay. So now I can define the decision problem because I have all the necessary inputs. Okay. Decision problems. Now, first I have the household problem, then I have the firm problem. Now, the household problem, remember there is a utility function. Okay, that utility function is this. So consumer is going to choose these things. Now, subject to what? Subject to, there is a consumption expenditure, all right? And that consumption expenditure must be less than or equal to income. So what is income? Income is W times H, right? Plus the profit. Okay? And there's another constraint, and that constraint is that we already defined. Okay? Now, if you want to write more specifically, there is a non-negativity constraint on consumption, and L and H should be between, of course, 0 and 1. So this is the consumer's problem. Now, importantly, consumer takes prices and the profit as given. Okay? The consumer takes profit and the prices as given. Okay? For any level of prices and for any level of profit, the consumer wants to find a C star, an L star, and an H star. Okay? The optimal values. Okay? Remember, these are, of course, endogenous variables, but for the household problem, they're going to remain as givens. Okay? Now, the firm problem could also be written as a profit maximization problem. So what is the profit? P times X times H beta minus WH, right? And here, firm chooses the labor demand without any constraint other than this. Okay? And again, of course, so this is profit as a function of labor input. And again, the firm will take prices as given. So for each pair of price and wage, the firm wants to find the profit maximizing level of H star. Okay? So these are the decision problems then. All right? Now realize one thing. Once we solve these decision problems, what do we have? We have from there a labor supply, okay? And we have from here labor demand. And then from here, we have a consumption demand, right? And from this, we have output supply, right? So these will be functions of prices, okay? These will be functions of prices. And in two markets, we're gonna have market clearing conditions, okay? In the labor market, we have that. In the good market, we have that, okay? So if I want to define the equilibrium, I'm gonna do that. Okay? A general equilibrium of this economy is a set of allocations. So what is this set of allocations? Consumption, labor, leisure, output, etc., right? And a set of prices, P and W, such that one, given P, W, and pi, C star, HS star, L star solves the household problem, plus given P and W, HD star solves the firm's problem, and finally markets clear, right? So that is the definition of general equilibrium. So general equilibrium is a set of prices and a set of allocations such that agents optimize, markets clear. Okay? Agents optimize, markets clear. All right? Now, our task, of course, is now to solve these problems first. Okay? We want to solve these problems. So it's very simple. Let's start with the consumer problem or the household problem. So we had this, right? CLH subject to PC less than or equal to WH plus pi, H plus L less than or equal to 1. Okay? Now you should realize this utility function is increasing in both arguments, right? So utility is strictly increasing in consumption, and utility is strictly increasing in leisure. All right? So this implies these resource constraints hold with strict equalities. Why? Because consumer will use all the resources. Okay? You can do a mathematical proof of this, but I'm taking a shortcut here because it is rather obvious, right? There will be no waste of resources because those resources always increase incrementally, though, always increase utility. Okay? So if that's true, I can write the utility function in this way. Maximize alpha, the natural logarithm of consumption. Now, consumption is this, right? From this, consumption is that. And from this, I have L equals 1 minus H. Okay? Now, the problem becomes only a function of HS, labor supply. Right? So we're going to take a first order condition here. Okay? I'm going to look at the derivative of this function. So I have what? First, I have alpha, right? Okay, we have less than 10 now. So first I have alpha, then the natural logarithm of this function. You may imagine that this has two parts, ln WHS plus pi and minus ln P. So forget about the ln P. So you have what? Alpha times. So write this as alpha times ln WHS plus pi minus alpha ln pi. Okay? So what do you have? You have alpha times W divided by WHS plus pi. right? That's the derivative. Then you have what? What's the derivative of this with respect to HS? It is equal to -1. Now, suppose that we are looking at an interior optimum. Okay? So there's no corner solution. This is for simplification. So this must be true, right? And also, you should realize that the second order derivative is negative, right? Remember, there's first order condition and second order condition. In the first order condition, you look at the first derivative being equal to 0. In the second order condition, you look at the second derivative and require this to be negative, right? For concavity, because this is a maximization problem. And if you look at that, the second order derivative is negative because HS is here in the denominator, right? So I have this that summarizes the optimality condition, okay? In fact, I can actually now solve it. Alpha W divided by WHS plus pi equals 1, right? From there, I have alpha W equals WHS plus pi. So I have HS being equal to alpha W plus pi, so sorry, minus pi divided by W. In other words, I have alpha minus pi divided by W. Okay, let me check whether this is correct because I have the solution in the yes, this is correct. Okay. Okay. So this becomes the labor supply. Okay. If this is labor supply, what is leisure? Leisure is equal to that, right? So it is equal to 1 minus alpha minus pi divided by W. So it is 1 minus alpha plus pi W. Now realize one thing. This labor supply function is a function of two things. One is the profit income, which is here, right? Profit income. And the other is wage income. And there is also this parameter that kind of governs the importance of the consumption for this person's utility, right? Now, what is going on here? Labor supply is increasing in wage and decreasing in profit income, okay? Which makes sense, right? Which makes a lot of sense because if I have outside income, I may work less for the same amount of consumption. And if I have a higher wage in the market, I would work more to benefit from these higher wages, okay? So conversely, your leisure increases with profit and decreases with the wage, okay? Okay, of course, these results on leisure and labor supply depend on preferences as well, okay? But this is what we get in this model, all right? Okay, so now we're gonna look at the firm problem. Oh, by the way, of course, we're gonna have consumption level as well, right? Remember, consumption depends on this, right? So C is given as WHS plus pi divided by P, okay? So you have the real wage times labor supply. What is labor supply again? Labor supply is this. Okay. Plus, you're going to have real profits. Okay. So if you further do the math here, you have consumption being equal to what? Alpha W minus pi divided by P plus this is divided by P. So consumption must be equal to alpha times the real wage. So profit does not affect the consumption. Okay, that's again depends on the problem, the fundamental assumptions, but that's the result. Let me also check this because I am doing this from fundamentals. Yes, that's correct. Okay, now let me very quickly write down the firm problem. Okay, remember we are maximizing profit, okay, by choosing H. So there is again a condition, right? P beta x h to the beta minus 1 must be equal to wage, all right? In other words, marginal productivity of labor must be equal to the real wage, okay? So from this, you can solve labor demand, okay? So it looks like beta x divided by the real wage 1 over 1 minus beta. If you do the math, you're gonna find this result. So what does it tell me? If the firm becomes more productive, then labor demand increases. If real wage is higher, labor demand decreases. Okay. So that's the end result of the firm's problem. And once again, if you look at the second order derivative, right? So first derivative of H is there. It is equal to 0 at the optimum. And the second order derivative is equal to beta minus 1 dot dot dot. So because of this term, it is negative. So this profit function is concave. Okay. Now I have less than a minute. We have more stuff to do. So let's meet at 10:40. Okay. 10:40. All right, people. We're gonna continue at 10:40. Thank you.